In this lesson, we're going to learn how to solve kinematics and projectile motion problems. Kinematics are a series of equations used to calculate velocities, accelerations, and time intervals. They can be used to describe the motion of objects. Looking into the kinematics formulas, there are a variety of formulas that we can use in many situations in which we have a set of given variables and we want to look for an unknown variable. Let's do some practice questions so that we can test out our knowledge of kinematics. A ball rolls down a hill with a constant acceleration of 2.1 meters per second squared. If the ball is at rest, how far does it travel in 3.5 seconds? While looking at this question, it looks like we are solving for displacement. We are given the values of our acceleration, 2.1 meters per second squared for our acceleration, and for our initial velocity, the ball is at rest, so it is 0 meters per second, and our time is 3.5 seconds. In this situation, the best formula to use would be delta D equals initial velocity times delta T plus 1/2 of acceleration times delta T squared. So plugging in these values, we have 0 meters per second times 3.5 seconds. This gets canceled out because anything multiplied by 0 is 0. And then 1/2 of 2.1 meters per second squared times 3.5 seconds squared. Rounding to two significant digits. Comes out to be 13 meters. Let's do another question. A ball is dropped from the top of a building. Ignoring air resistance, what distance has it fallen after 3 seconds? Now, it looks like we're not really given much, but there are maybe a few variables that we actually do have, but we just don't know yet. For example, the acceleration due to gravity is always going to be 9.81 meters per second squared. We also know that the ball initially has to start off with no velocity, so our initial velocity is going to be 0 meters per second. Now we know that the time is 3 seconds, because that's how long it took for the ball to drop. And finally, we are solving for the displacement, or how far it fell down. Again, the formula that we can use is delta D equals initial velocity times time plus 1/2 acceleration times time squared. So plugging everything in, 0 meters per second times 3 seconds, crosses out. Then we have 9.81 meters per second squared times 3 seconds squared. Our displacement is going to come out to be 44 meters downwards because it's dropping off of a building. That answers question A. Let's move on to question B. If the building was 100 meters tall, how long would it take for the ball to hit the ground? It looks like here we are now given a height of 100.0 meters. And now we are looking for the time. Now using the same formula, solve for the time to see how long it will take for the ball to hit the ground. So 100 meters equals 0 meters per second times delta T, those cancel out, plus 1/2 of 9.81 meters per second squared times time squared. times squared equals 100 divided by half of 9.81, so gives about 20.4 seconds squared. Now all we have to do is take the square root of both of these, and we can find that, rounding to 4 significant digits for this question, the time it takes for the ball to drop is 4.515 seconds. Seems simple enough, so let's move on to the next topic. Let's take a look at projectile motion. A projectile is an object that is launched, dropped, shot, etc., and follows a parabolic trajectory towards the ground. In other words, say you were an archer and you're standing with your bow and you draw back and you launch your arrow forward. The arrow is going to go straight, but eventually it's going to land on the ground due to the force of gravity. The horizontal or forward path that the arrow follows is called the range, and this is in the x-axis, while this value over here is the height or the y-axis. Looking at some rules for these projectile problems, time is the same in both axes. The time variable is special because we can use it with both axes, seeing as they're equal to each other. Acceleration in the y-axis is always going to be 9.81 meters per second. And in all of the projectile questions that you will see, it'll most likely be positive as the object is going to be working with gravity, going down, being positive 9.81 meters per second squared. The initial velocity is always 0 meters per second. Now this only applies to the y-axis, as the horizontal axis, the x-axis, has its own set of velocity. The horizontal velocity is always constant, and so there is no acceleration in the x-axis. Using these rules, let's try and solve some of these problems. An airplane drops supplies into a battlefield. The plane is flying at an altitude of 850 meters at a constant velocity of 51.5 meters per second. At what horizontal distance should the plane drop the supplies so that they will land at the drop point? So what are we solving for in this question? We are looking for horizontal distance. How do we calculate distance? And so if you want to isolate for distance, we have to find the velocity, and we have to find the horizontal velocity and the time, and multiply them by each other to get the distance. In this question, we are already given the horizontal velocity. Which is 51.5 meters per second. Now the only other thing we need is the time, of course. Remember how the time is the same in the x and the y-axis, so we can find time using kinematics formulas and then plug that in with this velocity to find the horizontal distance. So the other things that we are given in this question is that we are flying at an altitude of 850 meters. We also know that our initial velocity, another one of those rules, is 0 meters per second, and that our acceleration is 9.81 meters per second squared. Taking a look at this, it looks like we can solve for time with this equation. Displacement equals initial velocity times time plus 1/2 acceleration times squared. So 850 meters equals 0 meters per second times delta t, these cancel out, plus 1/2 of 9.81 meters per second squared times delta t squared. And then we just have to divide this 850 by this to solve for delta t squared. about 173.3 seconds squared. Then we can just find the square root of each of these to find the time, which comes out to 13.2 seconds. And now we can just find distance by multiplying our horizontal velocity, 51.5 meters per second, by our time, 13.2 seconds, rounding to 3 significant digits, 678 meters. Let's try another one. An archer shoots his arrow towards a target, giving it a horizontal velocity of 65 meters per second. If the target is 15 meters away from the archer, at what vertical distance below the point of release will the arrow hit the target? To visualize this, we have ground over here with the target set up. The arrow is going to go straight forward, and then it's going to dip down a little bit to hit the target. So we know that vertical distance, that is talking about the displacement, and that's what we're solving for. What we are given in this question is that the horizontal velocity is 65 meters per second, and the distance, the horizontal distance that the archer is away from the target is 15 meters. Again, we're also given that the acceleration is 9.81 meters per second squared, as well as that the initial velocity is 0 meters per second. So now that we have listed all of our given values, it looks like to solve for this displacement, we need to first solve for time, as that's the one variable that we're missing for our equation. We can easily solve for time as we already have the distance and the velocity. And as we know, velocity equals distance over time. So rearranging the formula, time should equal distance divided by velocity. So our distance is 15 meters divided by 65 meters per second to give us a time of roughly 0.23 seconds. Now using the formula, delta D equals initial velocity times delta T plus 1/2 9.81 meters per second squared times time squared. Plugging in all of our values, this gets cancelled out, plus 1/2 times 0.23 seconds squared. And after this, we should get a displacement of 0.26 meters, rounding to 2 significant digits. So far, these questions are, I would say, pretty easy. So far we've covered regular kinematics questions on the horizontal plane. We've calculated projectiles that are dropped or shot, but we have not yet covered projectiles that are launched in the air and then they come back down to the ground. So say that I was on a soccer field and I kicked the ball from here to here, and it followed this motion. Obviously, I had to have kicked it up at a certain angle. So let's call this 50 degrees. And I kicked it up with a speed of 20 meters per second. In these types of questions, you could be asked how far does the ball go in the end, or how long does it take for the ball to go from here to here, or maybe it can ask you what the highest point is. And at first glance, this may seem impossible to do. However, once we go back to maybe some grade 9 math, specifically trigonometry, and recall the SOHCAHTOA rules, we can figure out that this is a right angle triangle in which we can use an angle and a side length to find a different side length. Let's say, for example, we have this speed of the hypotenuse, and we want to figure out the horizontal speed. With this angle being our reference, a hypotenuse and adjacent side. For that, we would be using cos, which would be cos 50 degrees equals adjacent over the hypotenuse, which would be 20 meters per second. The adjacent side is about 13 meters per second, which we can then use to solve for time, and we can use the time to solve for other variables. But there are a few more rules that we need to go over before we can go into any questions. So for projectiles with angles, acceleration in the y-axis is always 9.81 meters per second. That's still true with it being positive going down, but negative going up, because you would be working against the gravitational force. Also still true, the horizontal velocity is always constant with no acceleration in the x-axis. Now here are some new things that we need to consider. The initial velocity is no longer 0 meters per second, but rather we must solve for it. And no, the initial velocity is not that 20 meters that we used in the example, as there is a different initial velocity that we must use in our calculations. Final velocity, however, is always 0 meters per second. An easy way to understand that is that when calculating any of these types of questions, we are only using calculations with one side of this big triangle, as on the other side it's the exact same. It's another 50 degrees going down here, and it's going to take the same time to go up from here all the way up to here as it will take from here to here. That being said, this point right here will be the point when the ball is going up, and it's kind of getting exponentially slower until it reaches no speed for a second, and then it'll gain its speed back exponentially as it accelerates towards the ground. But we call this point 0 because it is the top of this half of the triangle that we are solving for. And the final rule is that time must always be doubled. When looking at these calculations, like I just explained, we would only be calculating for this one triangle when there is a whole another half. So if we calculate a time in this triangle, we obviously have to double it as it's going to come back down. Now that we are educated on the rules, let's try some practice problems. A golfer hits a ball and gives it an initial velocity of 35 meters per second at an angle of 21 degrees above the horizontal. Question A asks, how long does the ball stay in the air? So first, it's always nice to draw out a little diagram for the question. So it looks like it's kicked up into the air, comes back down, goes up 21 degrees at a speed of 35 meters per second. So now we know that we need to solve for the time. What variables are we given? So we know that this velocity over here is going to be the final velocity, and it's going to be 0 meters per second. Since the ball is going up, it's going to be working against the gravitational pull, so our acceleration is going to be negative 9.81 meters per second squared. We almost have enough to solve for time. The only variable that we are missing is an initial velocity. Now, like I said before, this 35 meters per second is not an initial velocity. We must solve for it by using SOHCAHTOA. So from this angle, this 21 degrees, This 35 meters per second is the hypotenuse, and we're trying to solve for the opposite side. So therefore we're going to be using sine. So sine 21 degrees is going to equal opposite over the hypotenuse, which is going to be 35 meters per second. Our opposite side length is going to be about 12.5 meters per second. Now with all this information, we can now solve for time with the formula final velocity equals initial velocity plus acceleration times time. Plugging in, we have 0 meters per second, and then 12.5 meters per second plus negative 9.81 meters per second squared time. Now to isolate for time, we can either move this onto the other side of the equation, making it negative, and then dividing out the negative with this negative 9.81, or we can move this 9.81 onto the other side. Either way, our time should be 1.3 seconds. However, this is not our final answer. Remember, we've only calculated the time it took from it to go from this point to this point, but we also have to calculate the time it takes to get from this point down to this point. So all we'd have to do is multiply this answer by 2, which gives us about 2.6 seconds, rounding with 2 significant digits. This answers question A, so let's move on to question B. How far horizontally does the ball travel before hitting the ground? In this instance, we are now solving for horizontal distance, which we know equals velocity times time. We already have the time, which is 2.6 seconds. And now all we have to do is solve for the horizontal velocity. So remembering back to SOHCAHTOA, it looks like from this angle, looking for this side length, we need the adjacent and the hypotenuse side. Therefore, we're going to be using cos 21 degrees equals adjacent over the hypotenuse, which is 35 meters per second. Our adjacent side length will be about 32.7 meters per second. Now all we have to do to find the distance is multiply this velocity by this time, 2.6 seconds, which should give us about 83 meters, rounding to 2 significant digits. Let's do another question. A batter hits a ball and it is caught 5.2 seconds later, 125 meters from home plate. What is the initial velocity of the ball? So again, let's draw out a little sketch to visualize everything that's happening here. The ball goes up and it goes down and it lands 125 meters from home plate. So roughly here is our midpoint, and this whole distance is 125 meters. And in terms of time, this takes us 5.2 seconds. Question is asking, what is the velocity that it is initially launched at? To do this, we have to go back to our fundamental trigonometry rules. Just like we used in the previous question, SOHCAHTOA, to use an angle and a side length to find both of these side lengths, we can kind of do the reverse and use these side lengths to calculate this side length, giving us the initial velocity that it was launched at. We can find the velocity over here, as calculating the velocity can give us this side length. Remember, velocity simply equals distance over time, in which we have both of these values. So 125 meters divided by 5.2 seconds, which gives us a velocity of about 24 meters per second. This gives us one of the side lengths. We just need to figure out the other one. To do this, we need to incorporate some of our other values that we are always given. The acceleration is negative 9.81 meters per second squared as we are going up, acting against the force of gravity. Our final velocity is 0 meters per second. And we just need to solve for the initial velocity, which will give us this side length. Using the formula, final velocity equals initial velocity plus acceleration times time. We have 0 meters per second equals initial velocity plus negative 9.81 meters per second squared times the time. However, we need to remember that we cannot just use this 5.2 seconds, as this is the time for the entire motion. We just want to figure out this velocity, as it only covers half of the entire motion. So that being said, we need to take half of the time if we want to figure out this velocity, which would then come out to 2.6 seconds. Now, after doing a simple calculation, we can find out that the initial velocity is 25.5 meters per second. Now, using Pythagorean's theorem, c squared equals 24 squared plus 25.5 squared. Being lazy, always include your units. Then we can just take the square root of both of these, and c, or our initial velocity that the ball was launched at, comes out to be 35 meters per second, rounding to two significant digits. If you've made it this far into the video, chances are you're learning a lot and enjoy the content. So if you don't mind, consider subscribing and dropping a like on this video, as it shows me that you like what you see, which helps me post more videos. Anyways, that's it for now. I wish you well and hope you have a good day.